Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and in this final video I will summarize the details of the previous three videos on difference, sum, quotient, and division, and show you finally how we transfer from the geometric applications and properties to algebra through the abstract unit. So let's begin. Now, do ratios as we've seen in the past, and what we'd like to do now is develop a system whereby we can talk about the measure of these ratios without having to refer constantly to the geometry as we do down here. So now we can assign, suppose we had a standard measure for a unit, something like that, okay? And what we could do is we could assign any length to the unit that we want. We could call this the unit, but if we call this the unit, this particular representation here will be a fraction, okay? So what you're seeing in front of you now is this first row is translated by positioning these holy green and magenta dots on the orange one. Now this ratio has been transferred to this ratio with this consequent, okay? So now, and similarly, this ratio here has been transferred to this ratio with the same consequent. So now both these ratios have the same consequent, okay? And this is the consequent that they have. And as you can see, let's just leave it as it was. The consequent is that, okay? If we move it away, then it's no longer the consequent. So now both these two top ratios have the same consequent. And we could choose any particular ratio of equal magnitudes to be the unit, right? And once we've done that, then we can start assigning names. So, for example, we could call this the representation of 1, this first ratio. The second ratio could be something like this, right? And then this, of course, here would be the representation of 2. And it makes sense because this line here is 2 times this, and this line here is exactly the same as this line. So this ratio here would then be 1, and this would be 2. And similarly, we could extend the properties so that we have the next number like this. Don't know what's happening with my mouse. The next number like that, okay? And that would be 3, all right? So this here would be 3. So it would contain 3 times the consequent in the blue line. Now, normally when we write these numbers down, the way we're going to write them down is as follows. So let's write it down as that, and let's reduce our consequent to the same size as this that I've chosen over here. And let's just place these one on top of the other. And now we know that we could call this 1. And the way we would write this is typically something like this. Oops, I didn't want to do that. I actually wanted to move that along here. Let me just move it along here. So, and I need to move that too. Okay, so one moment. Okay, so now if that's going to be 1, like so, and this is going to be 2, then the way we would write that is we would put a double colon in between them, right? Like so. Double colon. So represent 2 or just 2, right? And if I had to extend this guy like this, then this would represent the number 3, right? And 4 and 5, etc. So now we could have now we've established all the names. But because we know in algebra we don't care about the unit, which is given by this, right? We can actually just trash that away because its size doesn't matter. And moreover, because we're going to be dealing with fractions, we can also disregard this part and just use the name of the antecedent as the numerator. So the antecedent then becomes a numerator. So if we wanted to write 2, the measure of this ratio, this ratio would be 2 over 1, or just 2, right? Does that make sense? Okay, so I've written this up all in the notes, and you can study it carefully and see how it all works. And what I'll do is I'll give you a link to this free applet, and you can play with it and see how it all works out. And you can also turn the show numbers feature on. That's not exactly one. Now it is. Okay, you can turn the show numbers features on. Make sure that you position the points on a vertex, otherwise they'll have fractions in them. But here you can see that this particular measure is given by comparing the numerator to the denominator, right? And once we move past that stage, we don't really care about the size of the unit, so we drop it and we just use the antecedent. Okay, so really what's happening here is this is still adding, this measure here is still adding these two numbers, 2 and 1, to get 3. So the antecedent is 3 and the consequent is 1, and of course we're not going to write 3, 3, 1 like that. 3, 1, we just got, or 3, 1 like this. We're just going to write 3. And that's pretty much it. So, okay, if you're not already a subscriber to my channel, please become a subscriber, spread the news, and also visit my Odyssey channel where you can donate credits or dollars. I could really use that. And hopefully sometime in the near future I'll come up with another brilliant way of explaining either another fundamental concept or debunking some fallacious mainstream idea, or explaining a mainstream concept that even your math lecturers don't understand properly, like I have been doing in most of my videos. So that's pretty much it. My name is John Gabriel. This is New Calculus. And just before I sign off, remember to visit Mucky Fry's channel. It's a really nice channel. I'll put a link to it in the details section. And he's been going a little slow, but I'm sure he's going to start picking up with his videos. And you can learn a lot by following his channel, because he has a way of explaining things that is pretty unique and a lot simpler than the way I explain things. Okay, so that's pretty much it. Till next time, goodbye.